Hi, this is Pankaj Jairu. I am doing this screencast on the topic electric field due to wire of length L. So I have this problem which depicts a straight wire and it has current moving on it, and at a certain point perpendicular to its distance uh, we want to find the electric field. So I have this question which reads: a straight wire of length 0.62 meters carries a conventional current of 0.8 amperes. What is the magnitude of electric field made by the current at a location that is a perpendicular distance 2.9 centimeters from the center of the wire? Use both exact formula and the approximate formula to calculate the field. So basically this question is asking us to find electric field but in two ways. I mean, the one is the exact formula and the other one is approximate formula, or we can say electric field approximation. So for the first part I'm going to use the formula electric field due to wire equals to mu naught over 4 pi times the current I times the length, which means the length of the wire, over r, which is the distance of the wire from the point M where we want to find the electric field. Or for this question, this r is actually the d, distance from the wire, which is 2.9 centimeters. So I plugged in the value of L, I, R and mu naught to get this expression right here. B wire equals to 4 pi to the 10 to the minus 7, which is actually the value of mu naught, which in terms of physics we say permeability of vacuum. So 4 pi into 10 to the minus 7 over this 4 pi times 0.62 meters times 0.8 amperes, which is the current moving in the wire. So over this r, which is the distance of the point M from the center of the wire. By center here I mean the midpoint of the length of the wire. After plugging in the value, I got the value which is 5.49 into 10 power minus 6 Tesla. So we're done with finding the electric field on the wire by using the method of exact formula. Now the other method is using approximate expression. So in this method is not exact because we are eliminating some of the terms which could get a different value from our exact expression. So in this formula we suppose this radius r is much larger than the other one or much smaller than the length we are taking to length of the distance we are taking for a point where we are going to find the electric field. So mu naught I over 2 pi r, plugging in the value we get 4 pi into 10 to the minus 7, which is same as above, the permeability of vacuum, over 2 pi, which you get from the formula, times the current I, which is 0.8 amperes, and the distance r of the point M from the midpoint of the length of the wire. So after plugging in the value, we get the magnetic field due to wire, which is 5.52 into 10 to the minus 6 Tesla. So we can observe from here the value of magnetic field using two different formula for the same wire is different. The value using approximate expression was more than the value using wire, because in approximate expression we eliminated some terms which could possibly alter the values, but one thing is for sure, that the magnetic field came out to be pretty close. So, and another thing, the direction of the magnetic field, because the wire is going from left to right, and if we imagine a loop around it like this, then it would be moving clockwise. So for clockwise current, using right hand thumb rule, we get the magnetic field which is upward from the page of the paper. I mean perpendicularly upward from the page of the paper. So this solves the question and the idea of magnetic field due to wire. Thank you so much, Dr. Red Allen, for listening to this video. Thank you.